The last trick we'll talk about is sort of harder to summarize when you use it. I mean, the previous trick was if you have a rational function and you're getting 0 over 0, use this. There's no real one sentence explanation for when to use this last trick. You should have square roots. You should have addition or subtraction involving square roots. And that addition and subtraction should be occurring inside a fraction. What's more, this is something we could reasonably expect to take the limit of just by plugging this 9 in. So if we don't get a division by 0 error, we could take the limit of the quotients. I'm being fuzzy with my notation here just to write it quicker. Then in the numerator and the denominator, we can break this apart. We can break subtraction apart. We can take limits into square roots. The limit of the identity function, the limit as x approaches 9 of this. The limit of the identity function is just the limit c. Here we have the limit of x. Once again, this is just x evaluated at c. That was the second limit rule we ever presented. So if we don't get a division by 0 error, we do just evaluate this limit ultimately by taking this 9 and plugging it in here. But of course, I mean, you see that 9 divided by 9, we do get a division by 0 error. So we have square roots being added and subtracted. We have division, and we get a division by 0 error if you try to use our limit rules to evaluate the limit that way. And the general trick to this, we're going to go to whichever part of the fraction has the square root in it. And if this is subtraction, we turn it into addition. If it's addition, we turn it into subtraction. So we multiply by the conjugate of that thing. And because we don't actually want to change the fraction, You see, we're actually just multiplying by 1. We're certainly allowed to do that. We've just written 1 in a kind of funny way. And now we're going to leave this limit alone. And we're just going to simplify however we can. In the numerator, the square root times the square root gives us x. Minus 3 times the square root plus 3 times the square root cancels. Negative 3 and 3 gives negative 9. We could FOIL the denominator, but that would be a bad idea because we see that if we don't FOIL the denominator, we're going to be able to do some cancellation. The numerator and this x minus 9 cancel, and we get the limit as x approaches 9 of 1 divided by the square root of x plus 3. This is the limit of the numerator divided by the limit of the denominator, assuming that the limit of the denominator doesn't end up being 0. Sorry, this should have been a 9 there. The limit of this constant function is the constant. The limit of this sum is the sum of the limits. And let me maybe speed this up a little. That limit as x approaches 9 is going to wind up in the square root. The limit of 3 is going to be 3. This limit of the identity function is taken by plugging 9 in. And again, this could all break in an instant if we get division by 0, but we didn't get division by 0. We computed a limit of 1/6.